Good morning, everybody. We're going to go ahead and get started now. So thank you so much, everyone, for taking the time today to join today's webinar for the RealGUIDE treatment planning software. Once again, my name is Andy Mori from RealGUIDE Digital Technology Specialist team. And we're going to be going through the RealGUIDE software today as kind of an introductory module, demonstrating the different tools involved in working up a case and actually going through those steps for a partially edentulous case. All right, so without further ado, let's go ahead and jump into today's topics or today's agenda for the RealGUIDE software. So of course, RealGUIDE is a treatment planning software with design capabilities as well. And what makes it a truly powerful and really exciting software is how comprehensive it is. At the base level, it's a free treatment planning software, which is great. It's accessible to everyone for no cost for you to go ahead and import your files and work up your implant cases and create those virtual implant treatment plans. From there, you're able to upgrade your subscription if you're interested in design features like designing a 3D printable surgical guide. And while it's not commercially available yet, very soon the restorative module is going to be released as well, which is going to allow even more powerful 3D options such as virtual wax-ups and designing temporaries and things like that. But today we're going to take a look at the base structure of the software, the treatment planning aspect. So some things to take note of is this is, of course, the software when you, the home screen when you launch the software. You'll see that you have your list of patients. As you click on each one, it's going to have the associated projects and files that you've happened to upload for that particular patient. Another thing to take note is even though this is a local software, it's not internet-based. It does require an internet connection because you do need to log in when you're running the software. You are able to run the software in offline mode, but if you want to upload it to the cloud in order to share it with your different colleagues or with an outsourcing option, you are going to need that internet connection. Also, if you're paying for any subscription features, of course, logging in is what's going to validate that and unlock those features for you. But today we're going to go ahead and start a case as if we have a brand new patient. We just captured some scans and and files for that patient. Let's go ahead and go through how do we bring that into RealGUIDE and start working up this case from step one. So the very first step is going to be add patient on the top left-hand corner here. And we're going to go ahead and type in the name for our test, our example patient here, as well as the birthday and any notes that you may want associated with the case, restorative notes, medical notes, medical records. You're able to go ahead and type it there. And then we'll go ahead and click OK. So you can see our new patient's been created, and now it's bringing up an import wizard, basically prompting us to begin uploading files for this particular patient. Now, we don't have to upload everything at once. Say you only have your CBCT at the moment, or you only have your STL. Once we close out of this wizard, it's very easy just to click the import button to bring up that wizard anytime we need to import additional files. So you see that there's a lot of different categories that are kind of self-explanatory as far as what to upload. So you have the option of importing the 3D, which is of course going to be the CBCT, STLs of any digital impressions, wax-ups, any sort of digital models. And then you can see there's a couple of additional categories as well if you have patient photos or prescription forms and other important documents. So we're going to begin uploading the CT because that's, of course, going to be the #1 requirement for us to treatment plan. And you can see that there's a couple of different categories, mainly just to make it convenient. If you have your CT in a zip folder, you can upload the zip directly without needing to extract it. Or, of course, if you have a regular folder, you can select that option as well. The third option is going to be the double scan. That is specific to fully edentulous patients and the dual scan protocol. So we're going to go ahead and ignore that for now. That's covered for the fully edentulous workups. So I'm going to go ahead and choose DICOM folder because my CT is saved in just a normal folder. And here's the folder containing my CBCT. And we can see that progress bar as it imports all of my slices. So now I click OK. We can see behind that DICOM images now has one, as well as a little preview of my CT. And since I already have the STLs, I'm going to go ahead and import that as well. Once again, a couple of different categories that's relatively self-explanatory, as well as some additional options if you have very specific 3D images that you want to upload. So I'm going to go ahead and highlight anatomy because I want to import the STL I have of the patient's anatomy. And that progress bar is very quickly, so I don't know if you caught that progress bar, but you can see that it did indeed upload one 3D object. And this case also has a wax up, so I'm going to take this opportunity to highlight wax up and import that as well. So again, these STL files are a lot smaller. That progress bar was quite fast, but we can confirm in the back here that both of those did indeed upload. And once I close out of this upload wizard, you can see that there's my patient anatomy, there's my wax up. And then what's nice is in the DICOM images, I can scroll through a little preview of my CT as well. Just kind of verify the anatomy, make sure that I uploaded the correct scan for this patient, and also making sure that there's not any issues like missing data, anatomy cutoff, and things like that. But everything looks good. All my files are uploaded. I'm ready to begin planning this case. So I'm going to go ahead and click open on my CT to begin working up the treatment plan. So you can see it's gone ahead and uploaded the 3D rendering of our CT scan. So before we jump into the different steps, I'm going to go ahead and go through a couple of navigational tools as far as how to manipulate your images. That's going to be pretty consistent throughout the software. So the first is by clicking and dragging your left mouse button. That's going to be how you rotate your images. So you can see I can freely rotate our 3D. If I want to snap them to an orientation very quickly, there's this nice orientation shortcut on the bottom left here where you can see I can easily position my patient back to a frontal view or a profile view, for example. The right mouse button, clicking and drag that will zoom your image in and out. Now, one thing to take note of is where you right click is going to be the focal point that it zooms in and out to. So you can see that if I right click off to the side, that becomes the focal point for how it zooms in. So that's one thing to keep in mind. And then lastly, the mouse wheel, you can scroll your mouse wheel, and that's another alternative to zooming in and out. But by actually clicking your mouse wheel, that's what allows you to bodily move your image in the XY axis as well. And then at any point, if you want to return to the default zoom and positioning, we can click this reset button to reset the views. So now that we know how to manipulate our image, we'll go ahead and begin going through the different steps. You can see that the steps, even though we're able to easily hop back and forth between the different tools, it has been set up in kind of a very convenient, intuitive sequence to where it's kind of chronologically how you would proceed through this, through working up the case anyways. So the first step we have is our VOI settings. And the main thing to take care of in this step is the trimming. So we're going to turn on trimming. And you'll see that our 3D is now encompassed in a transparent box. And I'm able to adjust the size of that box by clicking and dragging these little yellow orbs. So the purpose of this trimming step is to basically remove any excess information that we don't need. You got to remember that a CBCT is a three-dimensional image of compiled slices. And even if there's not any anatomy, it's still capturing information with these blank slices off to the patient's left here. So by reducing area, I'm basically telling the software that, hey, this area of the CT doesn't really contain information I need. So it's going to go ahead and remove it, basically reducing our total image, not only to our area of interest, but also the amount of data that the process by minimizing we can help the software be a little bit more efficient. So the same applies to the spinal cord here. That's not important in terms of our dental implant planning. And then this patient was scanned with the little radiographic appliance that for our purposes today, we won't need either. So once I've reduced that to our area of interest very tightly, I'm going to go ahead and click permanently trim. And even though anatomically not much has changed, it has reduced the size of our CT significantly to our trimmed area. The alternative tool here is the sculpting tool, where I'm able to, if I want to, highlight start sculpting. And by left clicking, I can encompass specific areas I want to remove by clicking sculpt. So I did want to demonstrate that tool just for the purpose of this webinar, but generally sculpting isn't necessary. And even if you wanted to remove, kind of a small artifact like I just did, I generally recommend against it. The reason being is the sculpting tool is almost too powerful, ironically, in the sense that it's a through cut tool. Even though I'm merely cutting what seemed to be a small circular area, is actually making a complete cylindrical cut through the entire CBCT. So what will happen now is in that area, there's going to be a black void on the scan because that data was completely removed. And a lot of times, if we start sculpting all throughout the scan, that's going to start skewing our CT views, and there's going to be pits and holes all throughout the different slices. So generally, unless there's an artifact that's really interfering with the patient's anatomy that you think is going to cause an issue with the model merge, I usually recommend against doing excessive sculpting. So we finish our permanent trim tool. I'm going to go ahead and click next. The next step is our 3D settings. This really is more of a visualization tool. You can see that there's a couple of default templates where we have the patient's bone, but we can also set the threshold to the soft tissue or to the teeth, and even kind of this neat transparent x-ray view. And then also airway if applicable. And so those are kind of the default views, but of course with our threshold up here, you can see that we can manually adjust the threshold based on different densities and also kind of the intensity of how it's being filled out. So again, this step really is just a visualization step. If there's a lot of scatter, you can kind of reduce the threshold so that you have a clearer picture of the anatomy, but not too much value other than visualization, because once we're able to see the anatomy nice and clear here, we can actually go ahead and move on to the model merge, because once you register a model, we'll be able to work off of that nice clean model. So I'm pretty happy with how our 3D rendering looks. I don't really need to feel the need to adjust our threshold too much. So again, I'm going to go ahead and click next step to proceed on with our planning. So now you can see that we're on the data import step. We have our anatomy as well as our wax up that we imported earlier. So we're going to go ahead and register the model to the anatomy on the CBCT because of course that's going to be very important to bring the model into the proper positioning before we start planning and designing off of it. So I'm going to highlight my anatomy model and I'm going to go ahead and click matching. So as a default, matching is highlighted, and there's a couple of other options. There's keep original position, which of course we don't want to do because clearly it's not aligning with the CT. And then there's also same as, where you can bring it in to position in relation to some of your other files if they're related. So that doesn't really apply to our anatomy right now, but I'll demonstrate that step in a little bit with our wax up. But for now, we're going to go ahead and match it to the CBCT. So I'm going to make sure that's highlighted and click OK. And now you can see we have our 3D rendering on the left, our STL file on the right, as well as our CT views down below. So when it comes to matching the models, we are able to add some reference points like we traditionally have been able to in other softwares, where I just need to set a couple of landmarks for the software to utilize in order to merge these two images together. And of course, I want to make sure that I'm choosing the same teeth between the two scans so that the landmarks match. And of course, I want to make sure I have at least 3 spread throughout the arch so it has a lot of points to reference. And then normally we would click fit points, and then those would merge together based on the landmarks. But I'm actually going to go ahead and delete the markers because the tool that I want to demonstrate actually is going to be our assisted tool. So it actually has a really neat feature called the assisted registration, where they've actually developed an algorithm to kind of evaluate the surfaces of both this 3D and the STL as a whole, and with that algorithm merge it together. And what we found is that this assisted tool, at least from our experience, is actually quite accurate. 95% of the time, very minimal adjustments is necessary. Of course, that's highly dependent. If there's a lot of scatter and artifacts that's kind of distorting our CT to make it visually significantly different than the STL, then of course in those scenarios, the assisted may struggle, but for the most part, it does a really great job of doing a preliminary registration. And more often than not, when there's a lot of natural teeth, in those scenarios, very minimal, if any, adjustments are needed. So you can see with that assisted function, it brought that model in what appears to be a great and accurate position. But as with everything, we're going to trust but verify. And the way we're going to do that is to verify it through our 3 CT views below. So you can see that our model is kind of that peach color. So it's represented by that same peach color in the outline in the CT. And all I want to do is, as I'm scrolling through our scan, I want to make sure that the outline of the model is hugging nice and intimately with the anatomy on the CT. And you can see that that registration turned out really, really great. There's almost no discrepancy between the outline and the shape of the anatomy. And we can see that as we look through our 3 views, that registration is looking really, really good. And then on our final cross-sectional view here as well. So that merge looks really great. Now, if we did need to make any adjustments for any reason, I would simply over this purple multi-directional arrow, and you can see that I can drag my model in the XY axis, and then of course that applies to any 3 of our views. If I needed to make very minute adjustments, when I highlight over the multi-directional arrow, you can see that there's larger blue arrows as well. And I can click on those blue arrows to basically nudge my models in the respective positions, which is nice to not have to try to drag it by such a small distance. And if I needed to rotate my model, I would just simply hover over this blue wheel until my mouse cursor changes into that circular shape. And then by left clicking and dragging, you can see I'm able to freely rotate that model clockwise and counterclockwise. But once again, very minimal adjustments were needed. In fact, I don't think any adjustments were needed because that merge was really, really great. So I'm going to go ahead and click apply. And now we have our model confidently registered to our CT, and we're very confident that it's in the proper position. So now at this point, I can actually go ahead and turn off the 3D and do all of my planning and work directly off the model now that I trust its positioning. So up here is our kind of quick visualization shortcut. So you can see that I can quickly toggle between those templates from earlier, but I can also turn off the 3D completely. And as I mentioned, just work off of this model. So normally at this point, we'd be ready to proceed with implant planning. But since I do have a wax up for this, I'm going to go ahead and bring it in because, of course, that wax up information is going to be very valuable when planning the positioning and emergence of our implants. So with the wax up, I'm going to highlight it and I'm going to click matching. And this is where, depending how the wax up was created, a couple of different approaches can apply. So if this was a physical wax up where we had an Edentulous model, and then your lab went ahead and physically created a wax up on top of that model, and then it was scanned in again, then we will go ahead and, of course, use the matching tool and match it based on the existing teeth. However, you can see that this is actually a virtual wax up. This was an intraoral scan, and then the technician, whoever created this wax up, actually digitally designed it right off of that intraoral scan. So what's really nice about those virtual wax up is their relation to the model is retained even upon export. So what I can do is I can say, now that we moved the original STL file into a new position, go ahead and move into that new position as well in relation to your original spatial relation to that STL. So we can say same as anatomy. And now it's going to maintain that spatial relation and basically snap into the new position that we moved the STL. And now we are wax up nicely integrated into our intraoral scan there. So really nice advantage that virtual wax up provides, but of course, a traditional wax up that got scanned in, you would just repeat that merging process twice. Now, one thing to keep in mind as well is every time we click next step, the software does save our work, but any work that we do within the step before clicking next does not get saved. So at any point, if you're kind of doing a lot of work within a single step, but you're not ready to proceed, then just remember that it's usually a good idea to manually save it just in case. And then now when we click next step, it's time for us to go ahead and set our panoramic curve. So this is going to be a mandibular case. So I'm going to choose mandible. And the first thing we want to do is we want to make sure that the axial slice, which is represented by this yellow line here, is neutral in relation to the patient's anatomy. As you know, when the patient is being scanned, sometimes they can tilt their head, sometimes they're mispositioned. So we just want to make sure that the way the software is slicing through our images is neutral in relation to the patient, just so that our views aren't skewed. So with this yellow line, I essentially want to make sure that it's roughly parallel with the patient's occlusal plane, left to right, and then also anteriorly, posteriorly in our right image here. And once we have that set, I'm going to go ahead and scroll through our axial view down to the level of the ridge, to where we can see both the bone and the roots of the teeth. And now that I like how our slice has been positioned, I can begin left clicking to reconstruct our panoramic image. And you can see it reconstructing down below, and now we have our nice flat panoramic image. Right now it's in a CT view where you can see where I can scroll through the slices, but if for whatever reason you wanted more of kind of a traditional x-ray view, we can click TH, which stands for thickness, and we can change the thickness of the slice, and you can see the thicker slices does give you that kind of more traditional CT view. So now I'll go ahead and click next step. This is, of course, a mandibular case, so we're going to want to make sure that we are conscious of that mandibular nerve. So you can see we have that CT view of the pano. As I scroll through, we can make that nerve canal appear really nice and clear. And I personally like to begin left clicking and mapping through the panoramic image, and you can see I'm adjusting my slices so that every time I add my point, I'm adding it in the optimal view of our canal. And as I map through the pano, I'm able to keep an eye on this cross-sectional view here and just make sure that our nerve is in a good position buccolingually as well. And then as I continue mapping through, I'm going to keep an eye out on that cross-section, not only for the buccolingual position, but also for when that mental foramen shows up, so that I can go ahead and exit my nerve. So now that we have our nerve mapped, I'm going to click next step, and we are almost ready to begin placing our implants. The final step is going to be the teeth setup. Basically, this is where we're telling our software where we're going to place our implants. So of course, every patient anatomy is a little bit different. Number 30 is not going to be in the same place in this patient as it is in another patient. So we're basically telling the software, hey, number 30 is going to be roughly in this position. And then number 31, by clicking on the tooth chart and then going back here, is going to be roughly in this position. So this is just basically allowing the software, when we choose an implant for number 30, to go ahead and throw the implant in that general area. Otherwise, it does throw it in the middle of the scan as a default, which is not a big deal. We can always grab that implant, of course, and drag it posteriorly, but this does save us a little bit of time, make things a little bit more efficient. Alternatively, if we click Add Tooth, that's where we're able to go ahead and add Vita teeth if we wanted. So for example, just to demonstrate the tool, I'll go ahead and add a Vita tooth to number 18 here. But since we have a wax up, that isn't necessary. But in scenarios where you don't have a wax up, you are able to add a generic Vita tooth. So you can see I'm able to add number 18 there. We have our tooth encompassed in a little cube similar to the trimming tool, where by dragging the faces of those cubes, I'm able to basically stretch and compress the shape of our Vita tooth. And then I'm able to drag it to move it around. And also wherever my cursor turns into a circular wheel, I'm able to rotate my tooth. And you can see that we're able to adjust it in our CT as well. I can rotate it with that blue wheel, move it into position, and then I can check its positioning buccolingually buccolingually as well. And you can see I can play around with my own little virtual tooth. A couple things to keep note of is, of course, as you can see, everything I was doing was purely visual. I wasn't taking into account the patient's opposing dentition or their occlusion. Also, you can see that I can only stretch and compress it kind of on a general level of customization. I'm not able to go in there and actually edit in detail the different cusps of the teeth. It's just going to have a generic molar shape. So just keep in mind that in the absence of a wax up, this Vita tooth is nice for kind of spatial and angulation reference, but it's never going to be true restorative value like an actual restorative wax up. So just use that Vita tooth kind of with a grain of salt. But we have our site specified. We went through creating a Vita tooth. Now we're ready to go ahead and begin throwing in our implants. So when it comes to our implant planning, we have all of our different views available. If you click on layout on the top left, you can specify not only the layout you want, but the specific views you like to use. This is the particular view I like to use, so I'm going to keep it on this second option here. And you can see our teeth sites from earlier are in blue from us selecting it. So I can choose number 30 and say, hey, let's go ahead and throw in an implant in that site. You can see that RealGUIDE has a very extensive implant library, but you'll also see that a lot of them have a little cloud next to them. So what will happen is if you've downloaded RealGUIDE for the first time, all of the implant systems are going to have a little cloud because RealGUIDE doesn't come with any implants preloaded. It does so just to kind of save hard drive space on your computer because, for example, why have TECA implants saved on your computer if you don't use the TECA implant system, right? So when you use the software for the first time, you'll just need to click the little cloud for any systems that you do plan with, and it's going to download that library to your computer. And that's just going to be done for the first time. Once you have that finished, you won't have to do that anymore. Similar to how I don't have to do it now. And whenever you click on whichever system you want to place, you can see that it has all the different implants available. And when you choose one, their associated diameters and lengths as well. So number 30 is a molar site. I'm going to go ahead and throw in a 4.7 by 10 for starters, see how that looks. And you can see as I begin planning my implant, there's a couple of things to take note of. One is with our wax up, it's really, really nice to be able to see how that implant is going to emerge in relation to our wax up, making sure that we have not only a good surgical position, but also a great restorative position as well. The other thing you'll notice is that it gave me that anatomy collision warning, and it turned my implant red. So what the software is recognizing, it's saying, hey, this orange outline is your model. Your sleeve is actually crossing over into the model. It's basically telling us that it's impinging onto the anatomy. So in this particular scenario, while that collision is not going to stop me from any planning or designing, it is alerting me that there's a couple of surgical considerations to take into account. If I proceed with this sleeve, the way it's positioned, it's impinging quite a bit in the patient's soft tissue. So with this positioning, if I wanted to seat the surgical guide, I would probably need to reflect the tissue in order for the guide to seat completely or to seat properly without any rocking. So that is a couple of things to think about from the design aspect when you start having anatomy collisions and start planning the height of the sleeve. So for example, the surgeon would either have to keep this position and reflect prior to seating, or go with raise the sleeve and use a longer drill, which of course has its own surgical implications as far as, what is the patient's vertical opening that far posteriorly. We're placing a Zimmer Biomet implant, so you can see that it's also allowing us to specify the sleeve, whether we're going to use the large sleeve for the traditional Zimmer kit, or of course they have a new Z3D kit as well that you're able to sleeve and plan for. But you can see with the old Zimmer kit with the longer drills, that sleeve got raised up out of the tissue, and now we no longer have that anatomy collision. So I can go ahead and click apply once I'm happy with the positioning, and of course I can continue to fine tune the positioning in this view. And it's also nice to be able to look at the 3D and see visually how it's going to be emerging in relation to our wax up. The implant and sleeve information is reiterated on the left here, and then you can see that we can specify the different drill lengths in that Zimmer kit if we wanted to. And you can see again with that shorter drill, it is giving us that collision warning. And another tool that I really like to use a lot is kind of in that cross-sectional view. I like using the bottom scroller because that gives me 360-degree rotation around my implant for me to really get that nice comprehensive evaluation when I'm planning the implant in the bone. So we plan on number 30 implant. I'm going to click on 31 to place the second one. And this is also a molar, but you can see in this scenario, our bone is a lot more limited. And even with the shorter implants, we're not having a lot of room there because of that mandibular nerve. So of course, this again is going to come down to you as the surgeon, whether you want to be that close to the nerve or not. You can see we have our 2 millimeter safety zone here, which of course you're able to adjust in the settings as well if you want to customize your safety zone. So that nerve is encroaching a little bit on our safety zone there. But as I said, in these more challenging scenarios, of course, you as a surgeon would have better clinical and surgical knowledge than I would as far as, how you would like to proceed as a surgeon, burying that implant or perhaps exposing it and grafting, or perhaps even angulating it and correct it with an angled abutment. So you can see the power of the virtual planning in terms of being able to explore your explore your different surgical options virtually to kind of decide what approaches are available and which approach you're comfortable with as the surgeon. But now that we have our implants placed and our implant sleeves, this is pretty much a completed treatment plan. So at this point, you're able to export the implant report, which is just going to give a comprehensive PDF as far as the material information of the implant and the sleeve, and also different views of where we placed it in the bone. You're able to generate a drill report as well, which is going to give you the drilling sequence for your kit. And then, of course, if you wanted to, you could take that report and go ahead and freehand the case, or if you wanted to proceed as far as guide design, then at this point with the implant and sleeves placed, you'd be able to proceed with guide design for export. But that pretty much covers everything I had on the agenda for today. We went through the time a little bit early just because there weren't any questions asked. Before I do go ahead and conclude today's webinar, I did want to open the floor, see if there's any questions, concerns, in case any of y'all were saving your questions till the end here. And I do know that obviously since the questions have to be typed, I'm going to go ahead and give about 2 to 3 minutes in case anyone's trying to type in a question right now. So we have a question coming in asking if this software does work with the Zimmer Biomet Navigator system, and yes, it certainly does. I can go ahead and change our implants here, and you can see that Zimmer Biomet is grouped under one. So if I scroll towards the top, here are different Biomet implants. So you're able to go ahead and plan whichever Biomet implant you use, and you can see the sleeve has adjusted accordingly to that Biomet 3i Navigator sleeve for the Navigator system. Yeah, you're very welcome, sir. Any other last minute questions before we conclude today's webinar series, or webinar session, I should say? All right, well, unless there's any final questions, I'm going to go ahead and conclude today's webinar. Once again, I would like to thank everyone for taking the time out of their day today to join the webinar. I hope you found it helpful. I hope you're excited about the different features and the power that RealGUIDE has to offer for you as a digital dentist or lab. So we're very excited to work with you and provide you with all of these different tools. At any point, if you have any questions, concerns as you begin playing with the RealGUIDE software, definitely don't hesitate to reach out to myself and the digital technology specialist team. Our direct number as well as an email contact form can be found on realguide.com, the RealGUIDE website. So you're more than welcome to shoot us an email or give us a call, and we'll be happy to help you out. Otherwise, thank you so much, everyone. I appreciate your attention and your interaction, and I hope everyone has a great rest of their week.